Alright, so some application with the perpendicular bisector theorem and its converse. So copy down this figure and the questions and we'll answer it together. So in this diagram, we're told that WX is the perpendicular bisector of segment YZ. Okay? And part A, it asks us for what segment lengths in the diagram are equal. Alright, so we want to see what's equal, and then we obviously want to state why. So I'm going to write my answer down here. So here we go. If, let's see, what does it say? Line WX is the perpendicular bisector of YZ. So right away, right, if this is a perpendicular bisector, we know that segment YX, or actually it asks for segment lengths, so we should probably stick with the lengths being equal. So let me change that. So we're going to know that YX is equal to XZ. And if we think about why, that's going to be by the definition of perpendicular bisector, right? The definition says that this is going to be the midpoint. If X is the midpoint, then YX is congruent to segment XZ, which means that their lengths are equal. Okay? What else do we know? Okay. Well, W, we know, is on the perpendicular bisector. We can see that. So if W is on the perpendicular bisector of this segment, that means that W is the same distance from Y and Z. So that's going to then tell us that YW is equal to WZ. And that's by the perpendicular bisector theorem. That's what that theorem states, that if you have a point that's on the perpendicular bisector, it is equidistant from the endpoints of the segment. And then obviously the other thing that we know to have equal segment lengths is that VY is equal to VZ, and we could pretty much just say that that's given, right? Because we see that. Alright, so that's part A. Part B, it says, is V on line WX? So basically we're being asked here if V is on the perpendicular bisector. Well, this is referring to the converse of the perpendicular bisector theorem. So the converse states that if you have a point that is equidistant from the endpoints of a segment, so here's V. If V is equidistant from Y and Z, then yes, it's on the perpendicular bisector. Well, that's what's happening here. We know that V is 25 units away from Y and V is 25 units away from Z. So our answer here is yes, it is. And this is by the converse of the perpendicular bisector theorem.